Welcome back for our third example, and this equation is a little different if you can tell. Our unknown is no longer in the first term of our equation. It's in the second term now. So it reads 4 take away 5 times a quantity is equal to 7. But you know what? I just don't think that I like having that variable in the second term. So I'm going to cross it off, and I'm going to use a property called the commutative property. And the commutative property tells us that no matter forward or backward using addition, that the answer is still going to be the same. Just like my commute to work. If I travel 30 miles to school, I still have to travel 30 miles to get back home from school. So applying the commutative property, I took my negative 5x plus 4 is equal to 7. Tells the same story. And what is that story? Some number, x, some unknown, is being multiplied by negative 5, then it's being increased by 4, and is ultimately equal to 7. I can tell my story going down, and know that I am going to be undoing the story to figure out what x was before it was 7. In order to figure out what x was before it was 7, we need to use all of our previous knowledge with the additive identity and the multiplicative identity, the 0 pairs and the 1 pairs. All of this simplifying expressions now comes into play when we're trying to solve for variables. So beginning with my 7 and knowing that part of my original story was adding 4 positives, how do I create 0 pairs with 4 positives? I need to add 4 negatives. Going across, you can see it is equal to 4 sets of 0 pairs. Great, we're doing fine. Let's move up to the section. We see now that it's multiplication. Instead of 0 pairs, now it's 1 pairs because 1 is the multiplicative identity. So I know that the reciprocal of negative 5 is actually negative 1/5. So I take my previous answer of 7 plus 4 negatives is 3. And I take 3 times negative 1/5. Well, that answer leaves us with a fraction. X is equal to negative 3/5. So now that we have a solution, we have to check it. And you know what? Let's check it with both equations to see if the commutative property holds. So you can see that we took both equations and we're going to start on the left side. And we're going to replace our variable with our solution. 4 take away 5 times negative 3/5 is equal to 7. Using the multiplication, because that's first in the order of operations, I see that 5 times the quantity of negative 3/5 actually gives me negative 15/5, which simplifies to negative 3. And we know from before that when I'm taking away negatives, I'm actually adding the inverse. So we don't necessarily even have to do subtraction. Everything's addition. 4 plus 3 is equal to 7. Well, we know that's true. 7 is equal to 7. Let's test it on the other equation. With our variable, we're going to replace it with our solution. Negative 5 times the quantity of negative 3/5 plus 4 is equal to 7. Using multiplication first, since it's order of operations, we see that a negative times a negative will give us a positive. 15 fifths plus 4 is equal to 7. 15 fifths simplifies to 3. 3 plus 4 is equal to 7. 7 is equal to 7. That is true. We maintained our equality all the way throughout finding the solution. We found our solution to be negative 3/5, and bonus is that the commutative property held true for us, and we were able to rearrange the problem and make it a little bit easier for us as we were telling our story.